Hello, I hope you all are having a wonderful day. Today we are going to talk about sound. So, how is sound mapped into our computer system? Remember, as we all must know, our computers can only understand the language of bits. So, all the analog data of a sound wave must be some way or the other transcribed into bits, zeros and ones. Right? So we'll study some of the concepts of analog to converter, digital to analog converter, what is sampling rate, what is sampling resolution, analog and digital data. And it's a very small content, so stick around and make sure you're going through every second of this video because this would really help you in your exams. So if I had to talk about sound, sound has basically a period. Period is a time frame where one complete uh, wavelength is completed. So this is a beginning of a sound, and this is the exact position where this sound comes if we count in the place it was started. So for this part, this is where one complete wavelength happens. Gun there, it comes down, it goes up, comes down, comes at the point, goes up, comes down, here's the point. So from point here to point here is where one wavelength is completed. Now, how do we transcribe or convert or map this wave into bits? So we have a thing called sound amplitude. Amplitude is the highest point in a sound. So this point is an amplitude. This point is an amplitude. So the amplitude of a sound cannot be measured precisely, so approximate values are stored. And the higher the sampling rate, the precise is our sound data. So there are a few concepts we need to understand. Sampling resolution is basically using the total number of bits to take a sound sample. So basically a bit depth of a sound. So how many bits are we allocating to record a sample? Sampling rate is the number of sound samples taken per second. So the more is our sampling rate, the more is our file size. The higher is our sampling resolution, the higher is our file size. So because we're taking many samples of our specific per seconds. So if you're taking let's say 44,000 samples per second, it's going to be very precise. If you're taking 4 samples per second, it's not going to be very precise, right? And then what else we've got here? Sampling rate. So amount of sample taken. Sampling is a process of measuring the amplitude. So peak value is measured. Sampling resolution is the number of bits allocated for a sound sample. So and sampling rate is number of samples taken per second. So we'll cover all this topic. Analog and digital data. So this is the wave. The sound sine wave is the analog data, and using our amplitude we map them into bits 1010011010. This is done by analog to digital converter. So analog to digital converter is basically a transcribing thing for computers. It transcribes any analog data into digital data. So the sound wave is converted into zeros and one, which is basically digital. A digital to analog converter is something that converts digital zeros and one into analog. So a microphone is an example of ADC. The mechanical, the real life waves are captured by microphone. It goes to the diaphragm. The small copper wire vibrates according to my frequency. It creates electric. It affects the electric field, magnetic field of the magnet, and it converts the change or the disturbance is mapped in terms of bits. digital to analog converter. The electric signal changes the makes the diaphragm or the plastic of the speaker to vibrate. So this vibration produces sound, and which is converted into analog sound. So the higher the size of your speaker, the deeper the bass gonna be, the louder the sound's gonna be. This is why bigger speakers produce louder sounds, because more vibration, more bass can be produced out of it due to the huge size of the speaker. And we have sampling rate and resolution. If you increase it, the file size and accuracy is increased. As we're taking more number of samples per second, we're allocating more bits into the sample. So this is all you will need for the sound part. I will see you in the next video. I hope you're having fun. Have a great day ahead. Thank you so much.